Hey everyone, welcome back. Today we'll be doing another one sheet where we try to explain a really cool math concept in 3 minutes or less. Today we'll be asking the question, what if linear regression and decision trees had a baby? So starting with a real world situation, let's say we're trying to predict the revenue of a restaurant here on the y-axis based on the average Yelp review, so the average online review of that restaurant between 0 and 5 stars. And let's say all of our data looks like this, so each of these little dots is a restaurant. Now you can see the trend is generally positive, as we might expect, but there's kind of more local dynamics going on, and that might affect how linear regression or decision trees are going to be effective. So starting with linear regression, basically if I drew a line through this, what would it have to look like? Well, if I just have to draw one line, it's gonna have to kind of look like that, some kind of average. It's doing a good job generally, but not great for these local dynamics. Now what if I use a regression tree instead? So a lot of people think you can only use decision trees for classification, but you can use them for regression too, and how that basically works is that you split at different values, just like you would for a classification problem. It's just that the leaf nodes now contain some kind of average value within each of your splits. So in this particular tree, we've chosen to ask if the review is less than or equal to 1.5, and then if it is, we predict some value mu1. So that mu1 is going to look like this, so that's going to be the prediction for the first cluster, just this flat average prediction. Then we ask, is the review less than or equal to 4? And if it is, we predict mu2, and so that would be some kind of average value like this. And then finally we ask, is the review greater than 4? And if it is, we predict mu3, so that's going to be some kind of average value like this. You can see this is doing a little bit better than linear regression, maybe because it's taking care of these local dynamics, but we've lost the linear part, we've lost the local trends. And that's where we have this joint solution called linear trees. Notice the tree looks exactly the same as the regression tree. It's just that at these nodes, instead of having fixed values, which are kind of this average prediction within each cluster, the nodes are linear functions themselves, which is the powerful change here. So we basically say if the review is less than or equal to 1.5, instead of doing some fixed mu1, which was this horizontal line here, we allow to have a whole function right there, where you go ahead and put in the review and have a local linear function. Same thing, if the review is less than or equal to 4 and we're here, we allow some kind of local function here which better captures the dynamics, and a local function for this last cluster too. And so hopefully you're able to see by combining linear regression and having a local linear regression at each of the nodes, each of the leaf nodes of this regression tree, we're able to do a lot better than using either linear regression or regression trees alone. Okay, till next time.